Hello everyone, and welcome to application number 4 for our course Rational Choice Theories. So today we are going to talk about the difference between perfect and imperfect information in games and the difference between complete and incomplete information. So first, to illustrate this, we're going to be considering extensive form games. So on the left, I drew a standard prisoner's dilemma in extensive form, but it's not so standard because the way I decided to model it, player 2 can see player 1's move before choosing whether to cooperate or deviate, right? So player 2 has two decision nodes and can take a different action for each of these decision nodes, all right? The most standard way to model the prisoner's dilemma would be exactly using the same structure, except we would include an information set joining the two decision nodes of player 2. And this information set, represented with this dotted line, represents the idea that when player 2 has to make a decision between cooperating and deviating, or defecting, they do not know what strategy was played by player 1. They do not know whether player 1 cooperated or deviated. Whereas in the game on the left, player 2, when deciding, knows whether player 1 chose to cooperate or deviate. And so in this special case of the prisoner's dilemma, whether or not we include this information set will not change the equilibrium of the game, but in many other games it will. So here on the left, this would be what we call a game of perfect information. Okay? So not only do the players know everything about the structure of the games, the actions available to each players, the number of players, and the payoffs of the game, they also know which actions were chosen by other players before they have to play, right? Whereas on the right, this is a game of imperfect information, with the only difference being that player 2 does not know what action has been played by player 1 before choosing an action. So whenever you see information sets with more than one decision nodes, this will be a game of imperfect information. With strictly more than one decision node. Okay? Now let's move to the difference between complete and incomplete information. So an important point to note is that in both of these games, players have complete information because they will have complete information as long as they know everything about the structure of the game, i.e. what players' type is, what their actions are going to be, and what payoffs are going to result from different strategy profile. Let's move to an example of incomplete information. So the way we model games of incomplete information is going to be to say that nature selects different types for certain players. And remember that games of incomplete information will be games in which players may or may not know some information about the other players, such as the strategies, the type, or the payoffs. So here, what we choose to say is that player 1 can be of two different types, and this type is unknown to player 2. Okay, so player 1 can either be altruistic or self-interested, and the way we model this is we say, let's consider nature as a kind of third player, which plays first. Sometimes we call nature player 0, and with probability 1/3, they will face player 2 will face an altruistic player 1, and with probability 2/3, player 2 will face a self-interested or standard player 1. Player 2 does not have a type, so player 2 is always self-interested. And then I just repeated the standard extensive form representation of the prisoner's dilemma. And here I only changed the payoffs down here by saying that the altruistic types gets an extra 2 payoff for cooperating. They really like cooperating compared to the standard case. So we have a 6 here instead of a 4 and a 3 here instead of a 1. That's the only difference I made. And here, basically, a last thing I really need to model is going to be the information sets of player 2. So while player 1 knows their own type, they know whether they're altruistic or not, player 2 does not. So we have to connect these two decision nodes to represent the fact that player 2 does not know the type of player 1, and in both of these decision nodes, all they know is that player 1 chose to cooperate. Similarly, in this decision node and this decision node, player 2 only knows that player 1 chose to deviate, and they do not know whether player 1 is altruistic or self-interested. Finally, if we wanted to model the fact that player 2 does not know both the action chosen by player 1 nor the type chosen by player 1, we would connect all four of their decision nodes. So we would connect the pairs of decision nodes as we did before, and then we would connect the other two decision node because player 2 does not observe the action of player 1, and we would be left with one information set with four decision nodes.